So I've got to let x equal 14. I'm going to go right into my calculator. Negative 2 times 14 squared plus 24 times 14. Read the problem. Plus 145. And when I do that, I find out that there are, when I plug in 14, so this is all I was doing, negative 2 times 14 squared plus 24 times 14 plus the 145. And when I did that, I found out that there was 89 of those spotted trout after 14 weeks. 89 of the spotted trout after 14 weeks. All calculator work. As we turn the page, we're going to go put stuff into y equals. We did some graphs of these in class yesterday. Oh, I wrote with my Sharpie. I shouldn't have been. Oh, well. We did some of these graphs in class yesterday. Read the directions to yourself because it's so important that you're not missing like the details of what this says. And I have a feeling some of you just came at it and started doing it. Graphing is using actual ordered pairs. And then it says also, do not forget to write proper statements for the axis of symmetry, max, minimum point, domain, and range, and increasing, decreasing. Exactly like what's going to be on your test. Now, first things first, want to go, and I think some people are even kind of struggling still at this point with this idea. Go put it in. Even if you've done it all already once, we're going through the motions. It's going to make your test go that much smoother for you tomorrow. When I put this into my y equals, I had already got it. I'd already looked at this, and I have a table of values that I'm using. But when I looked at it, I realized that the parabola was just kind of, it was over here on the right, so I made my origin on my graph be a little bit, further to the left corner. That's not what matters. This is where I think a lot of you guys are like missing out on where do I go in the table to get information about this. I don't know where you guys are when you open up your table, but we should probably all be in a different place. Our table won't be sitting where everybody else is. Now, the thing that I noticed, and I remember doing this with you guys before, where's the vertex going to sit? It looks to me like the vertex is sitting above the 2. Now, why is that important for me to identify where the vertex is going to sit? Well, then, because I can move around in my table of values. Yeah, right there. Jacob or somebody, could you walk over and give him a hand? Or anybody would volunteer to give him a hand? So then, and maybe this is even more helpful for you all right now, I'm going to write down this table of values here that is the most useful for the graphing. And then I'm going to put it on. And if you notice when I write down my table of values, that vertex is going to be kind of in the middle of it. I'm going to watch how my values go up, max out at 4, and then start going down the same way they went up. So, say it again? Jacob said he doesn't know how to. Walk up here then and I'll do something for you. So I'm gonna, my table of values sitting here I'm gonna start in the middle of my table with the vertex, that 2, 4. And then I'm just gonna work my way around, -1 and 3, 3 and 3. And I'm just kind of building off, starting in the vertex. Where am I at? 0, 0, 4, 0, -1, -5. And I absolutely would expect that you're putting a nice collection of points on here. And then I'm using a marker. I don't think I want to use a marker. I'm going to grab a pencil. Now, one of the things that's not asked on this question, and I'm going to throw it on there, this parabola has zeros. Zeros are x-intercepts at, I'm going to add it down here. X-intercepts are 0, 0, and 4, 0. Where does it hit the x-axis? I've got those right there. That wasn't a question, but it's something that we need to recognize. That was sitting there yesterday, too, when we were working through those other problems. Where is the vertex? That's the ordered pair, 2, 4. Make sure you're writing it as an ordered pair. the axis of symmetry. It's an equation. X equals. Axis of symmetry is X equals, and you can sketch it on there. It's a line. X equals 2. That's the X value of the vertex. Now, when I want to start talking about, now let me put my max or my vertex up here, 2, 4. There it sits. Maybe I just label it, make it really green. There we go. My vertex is sitting up there at 2, 4. Well, is that a maximum or a minimum point? That's a maximum, but the value of the maximum is actually simply the 4. 4 is equal to the maximum because the max or min is simply the y value of the vertex. Don't give me the whole vertex pair, just give me the y value. The maximum is the y value of the vertex. Now, with all of these functions, we haven't had any context to the problem. So x is all of our real numbers, that nice double bar, x is all real numbers. Now your range always gives you information, or I'm sorry, your maximum or your minimum always gives you information about your range. That 4 is the highest value that your parabola is going to get to on y-axis. So the y has got to be less than or equal to your maximum. Now if it was a minimum, we'd say y is greater than or equal to. Now, the increasing decreasing is always related to the axis of symmetry. I'm going to write it twice. And I'm going to write the axis of symmetry twice here because I'm going to talk about what's happening left of the axis of symmetry. In this parabola, when I'm talking about splitting this in half left of the axis of symmetry, this parabola has got increasing y values. Increasing y values left of the axis of symmetry. It's on the left side of it. And decreasing y values right of the axis of symmetry. Once I get there, the y values start going down. The y values are going up until I get to that axis of symmetry. The axis of symmetry is 2. Why am I writing 4? Yeah, dang it all. Yeah, I got this here, and I'm like, crap, I just screwed them right up. The axis of symmetry is x equals 2. I went and grabbed that maximum point again. Oh, lady, don't do that again. Yeah, make sure you guys catch me on this next one, all right? Catch me on the next one. Now, I've got the points out of my calculator already for number 7. I'm going to give you guys those points. If you can put it in your calculator or you can follow along, do it. The XY pairs that I saw as being easy to graph for this one, let me write these with a marker. -5, -4, -3, -2, -1, 0, and 1. The vertex in this one sits at -2. So going into your table, you'd have to move around until you got to that point. And these values that I'm putting on here, I just had done this earlier and wrote them down to help me save a little bit of time. Now, my point being right here is when you get into these tables, you should have a nice collection of either 5 or 7 points that you could put on the graph. Miss G was just reminding me too, like these graphing and going through all this is like half the points on your test. Half your test is about these graphing problems. So I'm going to start out by graphing my vertex, -2, +2. That's a big old grid. And actually, I like these points better. -2, +2. Let me go -4, +4. And then 0 and 4. Maybe I can get these other ones in here. -5, I go up to 5, 6.5. It goes up to there. At -3, I go up to 2.5. Oh yeah, I can handle that. Now, the one thing I hope you guys noticed about this, on the last problem, I stopped off and said, what are the zeros or the x-intercepts? This one doesn't have any. Come down at the bottom here. No x-intercepts. This one doesn't touch the x-axis at all. It sits above it. It's never going to touch it. Now, vertex. -2 and 2. Make sure you're wrapping parentheses around it. What's the axis of symmetry? X equals -2. It's a line. Sketch it in there. X equals is a vertical line. Does this have a maximum or a minimum? And what is that minimum value? The y value of the vertex. What's our domain always? X is all real numbers. Range, directly related to the minimum. Are values of y going to be greater than or less than? Yep. Y is greater than or equal to that minimum. Now over on the other one, when it was a maximum, it was less than or equal to. And that stuff is on page 30 in your notes packet. Page 30 in your notes. Now, let me go do this last part correctly. This is all related to the axis of symmetry, which is x equals -2. Blew that on the last one. As we're coming up on the left, towards the axis of symmetry, my y values are going down, decreasing left of that. Once I hit, and I can see it, going up to that point, these numbers are going down. Then afterwards, these numbers go up. Then it is increasing right of x equals -2. I'm going to go on to the next one, and I have the table of values again. If you got your table of values, you can go back and graph it later. But and this will be a public video this afternoon. As soon as my day ends, I'll put it up on my YouTube page. Number 8. I've got the points for number 8. Let me give you which I grabbed out of my table. And some of you guys might want to grab a calculator from me today, just so you can kind of roll through this at home again. Now, the reason I'm starting where I am in the table is because, there we go, that vertex was at 3,6 for this one. So if you put it in your calculator, you should be getting these points out of the table. The vertex is at 3,6. You got to wiggle around at 3,6 to find it. I'm going to go plot my points. I like to start with my vertex. X is 3 up to 6. When x is 2, I'm at 5. When x is 4, I'm at 5. I just like to kind of start there and build around. Doesn't matter how you approach it, just get them on there. 1 and 2, 5 and 2, 0, -3, and 6, -3. Now for this one, just to throw that one last thing back on here about the x-intercepts, I'm going to approximate these x-intercepts. It looks to me like these x-intercepts are about 0.5 and maybe 1, 2, 3, 4, 5.5. X-intercepts are approximately a half an x-ints. .5 and 0, and what did I say, 5.5? Where does it hit the x-axis? There's 2 of them here. Then I go back up. What's my vertex? That vertex was the 3,6 point. I'm going to go put that vertex up here. Vertex 3, 6. Axis of symmetry. It's that vertical line that goes right down through the vertex. X equals 3. Does this parabola have a maximum or a minimum point? It's got a maximum. It's that y value of 6. What's the domain? X is real numbers. What's the range? Directly related to the max. Y has got to be less than or equal to that 6. No y values are ever going to go above 6. And then my increasing, decreasing is related to the axis of symmetry equation. Y values are increasing to the left of x equals 3. Once I hit that x equals 3 on the right, the y values are decreasing. Now hopefully this is getting a lot more clear. Once I finish this last problem here, I'll stop off, and anything you guys want me to go back to, I will be glad to do that. Now, the one thing I noticed before we even go into number 9 is that the vertex this is in vertex form. The vertex is going to sit at 4, -5. And so knowing that, like when I went into my table of values, I got it into my y equals. I knew just by looking at the equation that that vertex was going to be 4, -5. There it is. And then I found values around it. 1's -23. I don't think I'm going to graph that. 2's -13. 3's -7. I hit my vertex, and then it acts the same way going back down. This parabola is opening down. And so I can take these points now. All right, let me go start here. Where is my vertex? 4, -5. 1, 2, 3, 4. Down 1, 2, 3, 4, 5. 4 and -5. I'm going to put on my 3 and -7. I'm going to put on my 5 and -7. I think I can get the 2 and -13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that's going to be mirrored across here at 6 and -13. And again, you guys, this problem has no x-intercepts. It never hits the x-axis. It has no zeros, no x-intercepts. It never hits the x-axis. I just want you to be prepared for them, and it wasn't on here. If we had, if you were asked, you'd know what to do. Deshaun. You need to graph it with at least 5 points. And I don't know what, like if your grid is in like you've got your XY axis in a little different place, I still should be able to see the shape of your graph like mine. Is that kind of what you're getting at? Yeah. Yeah, like he says, what if I don't draw what if I put my grid somewhere else and it's over here? Once you look at the graph, and I looked at my graphs in my calculator before I did anything. When I looked at the graph in the calculator, since this one was over, it was kind of down lower to the right, that's why I chose to draw it that way.
So wait, when you put the graph on the calculator, that's where you get the table from?
Yep.
Oh, for real?
Wow.
I hate this.
Sorry, maybe I shouldn't have wowed. 4 and -5 for the vertex. Axis of symmetry is going to come right down through that vertex. X equals 4. Do I have a minimum or a maximum point? I have a maximum. My maximum is -5. My domain my range is directly related to my maximum. Y is never going to be bigger than -5. Y is less than or equal to -5. And again, that page 30 tells you like something about like the maximums, the Y value of the range is the Y value of the vertex. It talks about that. And then last but not least, don't screw this up, Nikki. It's all related to the axis of symmetry equation. As it approaches the axis of symmetry going to the right, it's increasing to the right of x equals 4, and it's decreasing left of x equals 4.